brought this little crib sheet out because I need its help to introduce Vaclav Smil, other than the fact that he is a member of a new Czech conspiracy that I've uncovered today. What do Smil and Hosak and Znaimer have in common? I only realized it this morning. Holy cow. I'll explain a little later. But polymath. Polymath is just a word till you meet Vaclav. These are some of his areas of professional interest: environmental, energy, food, population, economic, and public policy studies. Since the early 1970s, he's also applied these approaches to energy, food, and environmental affairs of China. He's written 20 books, 250 articles published. By the way, books, they're out in the lobby. If you haven't had a chance to just connect from the speakers to the works that you can take home, you should. I find that stuff irresistible and always walk away with a big bag of great reading. And speaking of reading, Vaclav is an eclectic reader and listener with preferences for modern literature and classical opera. Besides Czech and German, he has studied Russian, Polish, Latin, Italian, French, Arabic, both the literary language and the Egyptian dialect, hieroglyphic Egyptian, Chinese and Japanese. He runs, he skis, and he cooks, mostly Italian and Indian. He's the distinguished professor from the University of Manitoba and the fastest talker I've ever met. Lots of it.
Can I have the light, please? I want to see you, okay? I just always hate this thing, you know, looking into dark room. Can I have the light, please? I'm almost tempted to give a counter talk that some of us, I'm originally a biologist, some of us biologists think that life is an extremely improbable thing in the universe and we may be alone, but that would be 3 space talks in a row and I'm not going to do it. I still don't know what you people want and what you people are. I was listening to clapping yesterday and you seem to clap equally about everything people say. So how about a choice? As an incorrigibly interdisciplinary scientist, I always do many different things, so I've been preoccupied with about 3 big things during past 4 or 5 years. One of them could be titled facetiously, but nevertheless truthfully, meat-eating chimpanzees, or why it's almost a natural idea to lust for blood and muscle. The subtitle will be The Mad Cows, why actually it's not such a bad idea to be a vegetarian. They go together. That will be a choice number 1. The choice number 2 would be the new economy, while it isn't, and it's like, you know, the Hans Christian Andersen's famous fairy tale, it has a naked king. The third one would be, that's my favorite actually, it is not television like these behind us, it is not a nuclear bomb, it is not radio, it is not flight, it is not space flight. What is the single most important invention of the 20th century? Which one of these 3 you want? The meat thing, the new economy thing, or the biggest invention of the 20th century thing? Okay, biggest invention, that's a good choice. I would have said about anything. It is fascinating because most people don't know what it is. You ask people, and we've done that actually, and people say predictable things, right? You know, flying, Wright brothers and Lindbergh and so on, and then Boeing 747. So flying comes up, people think flight is a great thing. Some people think the destructive or constructive power of atom, nuclear energy, nuclear bomb. And of course, many people would think internet, and until last year, most people even thought like JDS Uniface or Nortel or something like that, right? Okay. Let's start with stars. We just heard this beautiful talk about cosmos, that these strange things called amino acids are in the universe. The amino acids are relatively simple organic molecules, but they are distinguished with the presence of one important element which is relatively rare on the Earth, and that's nitrogen. And you need amino acids to combine to produce proteins. And you need proteins for everything which makes us human, for your brain, for your eyelashes, for your skin, for your guts, for your heart. You could be eating all the sugar in the world and you cannot grow a human body, nor you can grow a cheetah body or koala body. So we need proteins. So to make us what we are, to make anything animal or insect unique proteins. We cannot synthesize our amino acids. We can build those proteins in our body, but we have to ingest those amino acids, which means we have to eat, like cheetahs and like koalas, we have to eat. So without amino acids, that is without nitrogen, without proteins, there is no life. How do we get it? Obviously from crops. We plant crops and we either eat them directly or we feed them to animals, and that's a simple story. So, you know, there's nothing remarkable about that. It's a natural process. That's fine as long as you have 100,000 people or a million people. About 2,000 years ago, there were only about, whatever, you know, say 100 million people. Then you get into billion and it's still fine. You simply plant your crops and you eat the stuff and no problem. Once you are getting over something like 1 or 2 million people, you get 1 or 2 billion people, you get into problems with your protein, because there is such a shortage of nitrogen in the world that the natural processes are not sufficient to supply enough of it. Naturally, there are only 2 ways how you can get what we call the reactive nitrogen into organic compounds. When I wave my hand is touching 4/5. What it is bumping into are the molecules of nitrogen. There is no shortage of that thing in the air, but it's totally non-reactive. It's one of the strongest bonds in chemistry, actually, and it's very difficult to break. There are only 2 processes, natural processes, which can break that bond. One is lightning, and so especially in the tropics, there is lots of lightning all the time strike. As I speak right now, there is about 100 lightning flashes before I finish the sentence going down in Amazon, in Central Africa, in Indonesia, and that lightning is able to pry those 2 atoms of that nitrogen molecule apart, and once they are free with nitrogen, they can combine with other elements and they can create reactive compounds. And it rains down and basically it fertilizes the earth, and the plants can take up that nitrogen and they can create those amino acids, and, you know, monkeys, and we can eat them and everything is in order. So lightning is one process, but think about this. Let's have this box here and let's stuff these figures there. Lightning globally generates only about 5 million tons of nitrogen a year. 5 million tons, okay? That's all what's to it. The other process, which is a very natural process as well, is a different one. It's run only by bacteria. We have something like 1.75 million species we have described on this planet. You know, insects, bacteria, animals, most of these are actually insects. But out of these 1.75 million species we have described, only something like few hundred of them, 400, 600, 700, can do this trick, which we call the biofixation. These bacteria can take that nitrogen from the air, and using a special enzyme, they can pry that molecule. Instead of making it 2 nitrogen, they can make it a single nitrogen. Only bacteria can do it. And some other special things which we call now archaea, but which most people would easily mistake for bacteria. They look like it, they feel like it, they behave like it, but they are not really bacteria. They are something else because their genetic makeup is actually more similar to us than to bacteria, but that's a different story. So only these little critters which you cannot see, feel, taste, they can do the trick. Some of them can do it while living freely, you know, so you can take a scoop out of a brook and there are some of these bacteria there and they are everywhere in soil. But most of these bacteria are what you call symbiotic bacteria. They live in little pouches attached to roots of only some special plants. Again, there is a problem. We have something like 270,000 different plants, you know, trees and gladioli, but out of these 270,000, only about 10,000 of these plants are able to live in association with these special bacteria, which have that special ability because they have that special enzyme. It's like that fairy tale, you go step by step, to cleave that molecule of nitrogen apart. And these are legumes, things like peas and lentils and chickpeas and so on, okay? So these bacteria get carbon, which is the food which they need, like we need carbon, that's why I need all these sugars. They get it from the plant, and in return they are able to cleave that nitrogen molecule apart and give them nitrogen. These are the 2 only natural ways how to get nitrogen into the ecosystem, or in the case of what we are doing into agroecosystem, into producing our food. So traditionally, that's what we were doing. You know, we were planting legumes, and then we were taking everything which remains, that is our organic waste, human waste, animal waste, and recycling them. Now, here is the story. If you take the planet as it is right now, okay, and if you take all the crops which we have, if you eat them, if you digest them, if you create the waste, if you plant as many legumes as you have, and if you recycle all of that nitrogen, it will feed only about 3.5 billion people. Okay? Another 2.5 billion people would not simply be here. you have to divide between rich and poor. In rich countries, it doesn't matter. In rich countries, we have in places like Canada, US, and Russia. Russia is going maybe economically down, but it's a rich country. We have lots of farmland, so we just simply plant lots of farmland and harvest the crops with low yield and feed those populations. But in poor countries, like in India and China, it's a different thing. If they would recycle everything, if they would use all the natural nitrogen which comes from lightning, which comes of biofixation, which is done by those bacteria, China could feed about 600 million people. Now China has more than 1.2 billion people. Pretty much the same thing in India. So what has happened in 20th century, and this is why this invention is by far the most important, we needed to break the nitrogen barrier to bring the population of 1.6 billion people at the beginning of this century to 6.1 billion people now. And certainly has been the most important thing in 20th century. We have now 6.1 billion people, while we had only 1.6 billion people in the year 1900. That changed everything. You can easily imagine the life without flying. We were, commercial flight is only a matter of 1920s and 1930s. We just would take a ship. You still have a very high-class, affluent civilization without flying. We don't need nuclear electricity. Although it supplies now 20% of electricity in the world, we can get it from hydro. We can get it just simply burning more natural gas. We don't need it. So it's easily to imagine the world without that. And so on, we can go down the list. But you cannot simply imagine having these human bodies without protein, without nitrogen. Just simply that's it. Otherwise you just don't function, you don't exist. This has been an invention which, it's not a very difficult reaction. If you write it down, it's one of the simplest reactions there is in chemistry. 1 nitrogen and 3 hydrogens, and it makes ammonia, which is NH3. But it was very difficult to put it together because these 2 elements are very resistant to any combination. So what you have to do, you have to create high temperature, high pressure, and you have to come up with a substance which we will catalyze, which makes it easier for these 2 elements to combine. And people have been pursuing this for decades and decades and decades, and they were not successful at all. And what happened finally, that a German professor of physical chemistry, Fritz Haber, was successful in summer 1909, and he solved that reaction, but he solved it on a workbench. This wouldn't work commercially. So it needed a great deal of industrial development, which was mostly done by another German chemist, Karl Bosch, who was working for BASF company, which is still around and which is still making ammonia, which is still making lots of other chemical products. And the first commercial plant came into operation in 1913. Made little difference because the First World War came around. Then, interwar period, economically not so heavy. So we had to wait until the Second World War, and then the things exploded after Second World War. In 1950, we manufactured about 5 million tons of nitrogen per year. That's about as much as those lightning strikes manufacture. Right now, we are manufacturing about 100 million tons of nitrogen per year, and about 80 million tons of nitrogen as ammonia, and about 80 million tons of it are used as chemical fertilizers. China alone is manufacturing and importing nearly 30 million tons of nitrogen every year. Right? India is close behind, of course, Indonesia, and so on and so on. So the story is simple like this, that without nitrogen fertilizers, which is something which is totally unglamorous, people don't pay any attention to it. Most of you have never seen ammonia. Most of you have never seen even an ammonia tank. Most of you don't know how it's used. But anytime you go to Seafair, anytime you buy the food, that's what you are living off. But more importantly, anytime you go to China, anytime you go to Egypt, anytime you go to Indonesia, every newborn little child you see, every little boy running around, with these water buffaloes or gathering some straw or just simply playing around, think of it that the body of his or her, of these children, is made out of proteins which are made out of nitrogen, which has come from ammonia synthesized by a Haber-Bosch reaction. It hasn't come from ammonia, which is natural. Every marginal child, every new child which is now being added in these countries is the creation of Haber-Bosch process, because these countries have long ago, China about 25 years ago, India about 10 years ago, they have run out of these options to supply the ammonia in natural way. So if you judge the technical inventions by the impact on the largest number of people, already simply it has literally, physically created something something like 2.5 billion people. And between now and year 2050, even with the smallest expected increases of population, we expect that at least another 2.5 billion people to be added to this population, perhaps as much 3.5. All of that addition will happen in Asia, Africa, and Latin America. Nothing will happen in Europe and North America. And out of these additional 2-3 billion people, about 70, 80, 90% of them will be there because we will manufacture more ammonia and put it on more fields and produce more food. So all the marginal, all the new rice, all the new wheat coming will be from ammonia. So this is the most remarkable invention. Julia, of course, it was invented in due time. It was rewarded in due time, this invention, by Nobel Prizes. Both Fritz Haber and Carl Bosch got Nobel Prize for this invention. And it's the most, it's the single most important reaction in chemistry now, commercially. It's the fundamental of life on the earth. It's just totally unknown, totally forgotten, and totally unremarkable. In the remaining time which I have, I tell you because it ties together with it, this remarkable story which we are now unraveling about, which is direct tie to this protein and nitrogen, about these chimpanzees and meat eating and not meat eating. You know, when we started to observe these apes, and of course gorillas are still very much in that category, they sit in the middle of this greenery and just munch on these grasses and on these big shoots, and totally vegetarian, totally herbivorous. And when we started to observe chimpanzees, when Jane Goodall started her work at Gombe in Tanzania decades ago, we saw that chimpanzees are like that, totally herbivorous. It took us quite a number of years of very careful observation to see that, that male chimpanzees take many opportunities. In fact, you know, every reasonable opportunity they have to hunt. And they are very adept hunters, and they like to hunt, especially colobus monkeys, and they try to dispose of them in a very gruesome manner. They just simply catch the monkey, and they just rip it apart alive, and, you know, they take these limbs, and they go on a high branch, and they wave that piece of that monkey waiting for the female to come. When she comes and offers sex, she gets a part of that freshly torn up colobus monkey. So there is no doubt in our mind that chimpanzees, and here comes the clincher, with whom we share 99.75% of our genome, are meat eaters. It's in their genes. It's been in their genes for about 15 more million years than in our genes, and we come straight from that line. So clearly, you know, we have this meat-eating background in our evolutionary past, no doubt about it. And as we evolve ourselves, we got even more to be meat-eaters because of this. Our brains are unusually large for an animal of this size. You get an animal of our size, a pig is a pretty good model always. You know, you get a 70-kilo pig, 70-kilo person. Our brains are much, much larger. This is an expensive, metabolic is a very expensive tissue to support brain. So something must give. What will give if you have a similar sized animals and one of them like us has this huge brain? What can give? The heart cannot give because we got to run, right? Liver cannot give, you know, you need it. Kidney, you know, these are the processing furnaces. You need them to process everything. So the only thing which can give is the gut, the intestines. You can shrink intestines if you want to keep bigger brain. How do you shrink intestine? Well, you start eating things which are more digestible. What is more digestible? Corn or roots or meat? Of course meat, really, right? So this is exactly what happened to us. Given the size of our body, we have a relatively small intestine. You know, you dissect koala, and koala is just totally filled with long intestine because it's munching on eucalyptus leaf. There is no nutrition in them. It's just awful stuff. It's actually poisonous. So, you know, most of the koala is just gut, okay? So there is no doubt about not only that we get this meat-eating propensity from this evolutionary line of chimpanzees, but we get it also from the fact that we develop unusually large brains. So meat-eating is utterly natural thing for us. We are naturally omnivorous. We will eat absolutely everything, right? Carrions, you know, we used to eat lots of that stuff, lots of meat, any vegetable thing. So we are natural meat eaters. There is nothing, the argument, you know, that we are sort of evolutionary vegetarian is absolute nonsense. However, then you look at what has happened recently, and that's a different story. Until very, very recently in our evolution, we always ate meat. But what is fascinating is this. We've done these very, very interesting calculations that if you take, we have now data on meat-eating chimpanzees from 4 different locations in Africa. You take this and you prorate it for the size of the human body. Say chimpanzee is 35 kilo, we are, let's say, 70 kilo. Okay, so we should eat about double as much. If you prorate it that way, you see that traditional societies, let's say France in 1820, China in 1950, right? Very traditional agricultural societies people were eating about as much meat per year per capita as those chimpanzees were eating, prorated per larger human body weight. So it was very normal. So we were eating like what? We were eating maybe 10 kilo of meat per year per capita, 12, 8, something like that, mostly between 5 and 15, right? So we kept being chimpanzees until about, in rich countries, until about a century plus ago, and in poor countries like China until about 50 years ago, and India still very much so, right? So we haven't broken that evolutionary line in terms of meat eating until only about last century in places like Canada, US, and last 50 years in Japan and China. Where we are now at is something truly obscene. In this country, the average is, including babies and toothless grannies, the average is now 120 kilo of meat per year per capita. Okay, that's what we call in science an order of magnitude. That's 10 times more than we should be eating being normal chimpanzees, right? 12 versus 120. So what has happened is obscene, has nothing to do with natural omnivory of human species. We are, to say that we are overeating meat is not even to describe this thing, right? The trend is everywhere around the world like that. Japanese now are about 50 kilo. Urban Chinese in rich coastal areas in Jiangsu province, Zhejiang, they are about 50 kilo as well. So it's climbing everywhere. Also, it's stabilized in some places, but it's stabilized at a level which is still very high, like 80, 90, 100 kilo. This is bringing tremendous problems for us because some of that meat is an absolutely crazy meat. Okay, and this is where the mad cows come in. Not mad cows because they have the mad cow disease. That's another problem. But cows are extremely destructive as far as our environment is concerned. There are good cows and bad cows. The good cows are the ones which graze somewhere in the Alps or in Alberta Rockies. These are excellent cows. You have to love them, and you've got to cherish them. They are great cows because they can do what we cannot do. They can digest the stuff which we cannot. Try grazing yourself, and you will see that very difficult to digest that stuff. Okay, so the grazing cows are great. They have no impact if you calculate it right. I can sustain 4 cows per hectare on this pasture, and you can sustain it forever, as long as the sun will shine for next 500 million years before the oceans will boil away, so you can have cows grazing there, right? There are cows to be cherished. However, that's not when you go to store. Most of the meat is not from those cows. Most of the meat is from what? We do not have any agriculture in this continent. We have just simply an enterprise which is feeding animals. 80% of our crops is going to feed those cows and pigs, right? 10% we export, and only 10% we eat directly, right? Everything is geared to those animals. So the animal is born, we put it in a pen basically, and we feed that animal and feed it, right? That's what's called feedlot feeding. And some of these feedlots house 70, 80,000 of those creatures together. No wonder if one creature gets sick, every other creature gets sick, and we have to slaughter them by millions, right? That's not rocket science. Everybody would understand that, right? So there is this problem that if you start feeding these animals, there are animals which are metabolically smart. Pig is metabolically smart. Pig has a metabolically very low basal metabolic rate, so it's a very efficient animal. So you can have, and I'll do these things in terms of actually edible, pure lean meat. You can have 1 kilo of lean pork because that's what people want, lean pork, not a total, So in terms of lean pork, you can feed about 5, 6, or 7 units of concentrate feed. That's a mixture of soybeans and corn. That's how we do it with our animals. So you take, half soybeans, half corn, feed it to a pig. About 7 kilo will get you a 1 kilo of very lean pork tenderloin. Right? Chicken, you need about 5 kilo of feed to give you 1 kilo of chicken breast. Right? So chicken is best. Okay. Next comes pork. If you have that cow, and if you take that calf, and after weaning, and if you start feeding with this mixture of corn and soybeans until it reaches the slaughter weight, and slaughter it's at 600 kilo or whatever, you need about 25 to 30 kilo of feed to raise 1 kilo of that beef, right? Naturally, the water consumption goes with that. The amount of waste generated goes with that proportionately, right? So you have to dispose of that waste, right? You have to put that water into place, and think of the fact that you have 70,000 of them together, right? In Alberta or in Texas or in Oklahoma. So this is a frightening thing. The feedlot fed beef is something utterly unbelievable, right? There are even better options, of course. If you would be like Chinese, which you aren't, you would eat carp. Carp is considered an absolutely deadly fish in North America, and nobody ever catches and eats carp, right? But East Asia, Chinese, Japanese, Vietnamese, they thrive on carp, right? Carp, you can just put it into a bin and you can feed it, right? So we have lots of this aquacultured carp. Aquacultured carp takes 1 unit of concentrate feed per 1 unit of carp meat, right? And as you know, in China, all is eaten. Carp is eaten, all of it, right? Oh, okay, maybe you don't eat the very head of the head and very tail of the tail, but otherwise you eat everything, right? So carp is 1-to-1. Even if you cut off the tail and head, carp is maybe 1-to-1.5, right? Carp is 1-to-1.5. Chicken is 1-to-4 to 1-to-5. Pork is 1-to-5 to 1-to-7. Feedlot fed beef is 1-to-25 to 1-to-30, right? So you see, it would be a rational society. You would outlaw that thing overnight, right? In this country, about 50 kilo of that stuff is eaten every year, right? In US, about 50 kilo is eaten, right? And as people are getting richer, what do they want to eat? More carb? Well, you guess again, right? Or beef, right? So there you have the problem. Everywhere, you don't have the carb stir fry around the world. You have McDonald's everywhere, right? So we are running into and something we'll have to give, because you cannot have, so about 500 million rich people are eating lots of this beef, 30, 40, 50 kilo per year. But imagine like billion people, 4 billion people, eventually 6 billion people wanting to eat this kind of diet, really. So this is extremely destructive in many ways. So if you will remember only this, that when you talk next time to, vegetarianism is racing through this continent now. So many people have so many totally unscientific, mad beliefs that there is nothing virtuous, nothing evolutionarily justifiable, nothing good about being vegetarian. Okay? We normally are omnivorous people. There is nothing wrong with eating meat, right? But in evolutionary terms, it's eating with moderation. Moderation being somewhere between 5 to 25 kilo per year per capita, which actually I can tell you as somebody who cooks every day, this is more than plenty. If you cook Chinese or Indian style, and if you take, one chicken breast and cut it up in small pieces and make curry for 3 people out of it, that's plenty of meat, right? Multiply one chicken breast every other day through the year, and it gives you about 5 kilo of meat or 7 kilo of meat or whatever, depending. So you don't need 120 kilo. This is more than twice the body weight of normal people in meat, and half of it in red meat. You don't need that to be healthy, but you don't need to abstain as well. So this is the meat story. I have no time left. Okay, so I'll talk about this time. Thank you.